Assalamu alaikum and good day. Greetings to you, Dr. Dang. This is Mohamed Ahmedalla from Real Time Devs. I'm here to start the presentation about our project, WaterWise. I'll start by introducing my teammates, Osama Abdul Hamid, Ahmedalla, Sung Jeong, and myself, Mohammed. So, what's our project? Our project, WaterWise, focuses on enabling farmers to care for their plants by notifying them of how and when to water them. The system is designed to assist farmers in saving water by providing accurate information on when to water their crops, by monitoring soil moisture levels and weather conditions in real time. It can accurately predict when crops require watering, reducing the risk of overwatering and minimizing water waste. The goal and objectives of such a project are to save the exceeding amounts of water using for crops. The scope of the WaterWise system includes the development of a user-friendly interface as well as the integration of the system with existing farm systems. Additionally, the scope includes ongoing support to ensure the system is functioning properly and providing value to farmers. The system aims to improve water conservation efforts in agriculture, increase crop yields, and promote sustainable farming techniques. Now I pass to my friend Osama to talk to you about the system software design. Thank you.
Hi, I am Ahmedalla Abdelhamid. I am going to show you our software design for WaterWise system. It starts with our use case diagram. As you can see, we are having 5 actors. They are the farmer, the WaterWise system with its own AI features, and 2 sensors, moisture meter, thermometer, and the last one is the transmitter that's responsible for sending data to the network. So our system starts with detecting the humidity, soil moisture, and temperature, then send them to analysis data to let the WaterWise analyze them and take a decision, then update the dashboard for the user with the farmer, and the farmer later on can view that. Then we have our component diagram that's consisted of 3 main packages. It starts with the devices, actuators, and sensors. So after the sensors send the data to the storage inside the cloud services, the data should be processed inside data analysis, then sent again to the decision maker to be taken and stored inside the storage, and send the data also to the dashboard charts to be displayed later on inside the pages and the user interface. Then we have our class diagram that's responsible for storing the records about the soil records and weather records. These records could have a daily average record for each about the humidity, the pH level, the soil moisture, temperature, and water level. For these records, it should be stored based on the device ID, which should be taken from the device table. Then the AI decision also needs to be stored based on the records and sensor, actuator, and other tables inside the class diagram. Our last diagram, is the package diagram, and we have 3 main packages. The first one is the interfaces, and as you can see, they are the thermometer, the moisture meter, and the network, and they are responsible about the actuators and the sensor activity. Then we have the rules that should be followed. They are the accuracy, the temperature range, and the max weight, and all of them are depending on the time. And last one is the software system, and we have the Java programming language that depends on the RTOS operating system. Now I will pass it to Song.
Hello, my name is Song Jin-yoon and I will explain the application UI prototype. So the first screen is splash screen, which will be the loading screen that gives the app the needed time to start. Next is connection code screen. Here, all the user needs is to key in the code that will be provided with the device into this field, and the app will register the device immediately. Next is the devices register screen. Once the user key in the device code, it will be registered and showed in this screen. So every devices will be appear in this screen and user can manage from one to one in one place. Next is device data screen. This screen displays the main function of updating the user about all the information needed to make sure that the probes are in good condition with the indicators displayed. So in here, we can see all the information such as soil wetness, humidity, temperature, and so on. That is all for me, and I will pass the next to Ahmad. Thank you.
Okay, thank you very much, Son. So hi everyone, my name is Ahmedalla, and in this video I will introduce you to the hardware prototype. So let's get started step by step. As we can see here, we have the components, which actually consist of the Arduino Uno, with the section which actually act as a laptop or a small unit to actually compute all the programming that we will do. Actually got a small CPU and a small RAM, so it actually acts as like motherboard with everything built in. And we have also the controller, which will work with the humidity and the thermometer sensor to connect to the Arduino Uno. We can't already connect the humidity and thermometer sensor immediately to the Arduino Uno. We need a controller among them to actually make the connection. So that's about it. And for the humidity and thermometer sensor, actually it needs to look like that, and that type of thermometers that we need, because it can be dipped into the soil. As we know, the device will be dipped into the soil, and it will be very important to get an accurate results. So moving to the second part of the components, you can see that we have GSM SIM modem, or the SIM card modem, which will connect the hardware and the software section. It will connect the hardware that we actually developing now to the application that we will use on the mobile phone. And how can we connect it? The SIM card will be actually have a plan which can send data from the antenna that you can see here, that small antenna, to the application, keep it up to date, and to keep the farmer up to date with the updates of the temperature and humidity levels. Moreover, actually we will have, as any device, we will have battery, controller, and solar cell. For the controller, this controller is mainly about the battery, and it will use the solar cell to get all the power. As we know, in Malaysia it's actually not that sunny all the day. We have like a lot of rain and so on. So that's why we need only like 3 to 4 hours of charging with the solar cell, which will make the device run all the day with no problems, with 3 to 4 hours of solar cell energy. So moving to the full design, as you can see here, we have the Arduino Uno controller, the sensor, the modem, the solar cell, and how actually all of them are connected together. We can see that on the left side of the screen we have the battery, controller, and the solar cell. All of them are connected together after that Arduino. And for the modem itself, we can see that there is a modem and antenna which is connected immediately to the Arduino. After that, we can see that we have the final design for the internals. The final design here consists of how actually it will be stacked into the capsule, which is actually like 20 centimeters height, 20 centimeters of height, and the diameter will be 15 centimeters to include all the devices. As you can see here, there is the Arduino, the sensor, which actually will be out of the capsule to be dipped into the soil, and also we'll have the battery in here inside, so it can't actually get water into it or any other thing from the into it. And for the parts actually will be out of the capsule will be the solar panel, and it will be tilted a little bit to get more sun energy, or as we say solar energy, so it actually will collect more sun. And here for the modem itself, and the antenna will be also outside the capsule to have a good network range, so it can actually send the data to the software itself that the user will have. So this is how it will look like from the internal side, and this will look like from the outsider side. So the final design shape will look like that. The solar panel will get out, the antenna, as we said, will be also out, and the two parts here will be dipped into the solar also out, so we can get a valid and really accurate result. So I believe that was all from me. Thank you very much for watching and listening, and see you soon. Thank you again.